Okay, in this section we will learn the Pascal formula and the binomial theorem. There's the Pascal triangle in front of you on the page. It's built using this formula that's written up here, but again, you don't need to know the formula if you know what to do. So the pattern goes like this. You're going to start with 1 and then 1, 1. And the next line, you're always going to start with 1 and always end with 1. And the middle terms are obtained like this. Adding these two together, you get basically 2. So again, the next line is going to have 1 at the beginning and 1 at the end. And you just add the middle two. 1 plus 2 is going to be 3. 2 plus 1 is going to be 3 again. So that's the next row. If you want the next row, you start with 1 and you end with 1. And you add 1 plus 3, then you get 4. 3 plus 3, you get 6. 4 plus 1, you get 4. And then it ends with 1. So as you can see, there's symmetry, right? Whatever is showing up at the beginning is also showing up at the end. So same thing over here. So there's so many things that are special about this triangle that there are like encyclopedia-sized books that have been written about this thing. And one of the reasons why I like it, or we like it, is because it helps us figure out things like these, right? It helps us figure out the 6 choose 2, 6 choose 3, or 5 choose 1, whatever, without having to have a calculator. And it's a very easy, quick way of getting the answers. So the way that you want to think of it is that this is going to be the 0 row, this is the first row, second row, and so on and so forth. And inside of each row, you're going to start with the first number always being the R0. So like for example, this would correspond to R equal to 0, this would correspond to R1. So if I wanted to mention this number right here by name, I can call it the first row, second number, or I could call it like this, 1, choose 1. Okay, so the one on top corresponds to the row number that we're in this case it's 1, so that's what you put first. And the second number on the bottom corresponds to the actual column that you're in this case you're in the first column. So the answer would be basically a 1 factorial divided by 1 factorial 0 factorial, which is the same thing as a 1. Okay, so if I want to talk about, let's say, this guy right here, what would I call him? How can I get the value? Well, first of all, what row is it in? It's 3, so I'm going to put 3. Then R0, R1, R2. So this is 3 choose 2. Okay, let's find out, is that right? Is 3 choose 2 the same number as 3? So 3 factorial divided by 2 factorial, and then 3 minus 2, which will be 1 factorial. So this is going to be 6 divided by 2, which is at the end 3. Exactly the same number that was in the Pascal triangle. So that's a pretty cool way of getting numbers out of the triangle. So now that we know that observation, let's look at the example 1. And it says use a triangle to figure out what 6 choose 2 is. So again, what 6 choose 2 stands for is that we're going to the 6th row and R equals to 2 here. So row number 6, so row 6, and column number 2, so column number 2. So here we go. I'm gonna go to row number 6 and row number 2. So how do I start, or column number 2? So this is column 0, so R0. This is R1, and this is R2. So the answer that I'm looking for is 15. Let's verify, is this true? 6 choose 2 the old-fashioned way. This is going to be 6 factorial divided by 2 factorial multiplied by 6 minus 2 factorial. So in other terms, this is 6 factorial divided by 2 factorial and then 4 factorial. Okay, so this is 6, 5, 4, 3, 2, and 1 divided by 2 times 1 times 4, 3, 2, and 1. So I can reduce some of these numbers, and I could reduce 6 and 2 to get 3 and 1. So at the end of the day, it is going to be 3 times 5 times 1, which is 15, divided by 2 times, 1 times 1 times 1, which is still 1. So 15 is the final answer, which is exactly what we saw in Pascal triangle. So it's kind of a nice way of getting the answer without having to do all of this math over here or without having access to a calculator. So in a similar fashion, I can calculate 6 choose 3. 6 choose 3 would be the 6th row and the 3rd column. So that would be basically the 20. So in this case, that's 20. Let's verify. 6 choose 3 the old-fashioned way. This is 6 factorial divided by 3 factorial. And then 6 minus 3, which is 3 factorial again. So let's go ahead and write it out. let's cancel out some things. The 3, 2, 1 cancels out. The 3 times 2 is going to be 6. It cancels out with the 6. And we're left with 5 times 4, which is 20. So it turns out that, yes, it actually works.